Selamat sejahtera, tuan-tuan dan puan-puan, and the top management of MASTI, and ladies and gentlemen. My name is Chee Mun, and I am the Chief Product Officer for Right Bank, and the CEO of YTL AI Labs. I have two posts, not because I like to work hard, it's because YTL, when they give you one paycheck, they need two posts. I'm kidding, my boss not here. So, okay, today we're gonna talk about how AI agents will reshape a lot of our lives and our industry. So, I have 45 slides and 30 minutes, so we're gonna run through a lot of stuff. And so how do we define AI agents, right? And what we want to do is to contrast it with a regular software. Regular software are tools, and AI agents, however, are intelligent systems that can perceive the environment and decide on behalf of the users to achieve specific goals, right? So that's what we want to define AI agents. And throughout the presentation, I will demonstrate how AI agents are being developed and deployed in the real world using two examples that we have in YTL, right? So, and there are rapid advancements in autonomous systems, especially with in the age of generative AI, and I will explain why there's a sudden explosion in this particular discipline. And thirdly, I think AI agents has already changed a lot of the world, and I think for the next 2 years to 3 years is going to completely transform the world in ways that is hard to predict. So first and foremost, we just want to have a slight historical foray. Before the generative AI computing, what we had was von Neumann computing. So what does that mean is that to make the computer to do something for you, you have to speak the computing language, such as Java, such as Python, and everything else. And what it does is that it takes the computing language, or you tell it to do something, and then it has deterministic output. What does that mean, right? That means that every time you enter the same code, the same output will appear from the computer. So what it does is that it has explicit programming, symbolic reasoning, it's extremely input and output based, software abstraction layers that has from applications to frameworks to operating systems and to programming languages. And it's rigid interactions with the users and the computer. So the next thing that we have, which is the era that we are in right now, which is called the large language model, computing model. What it does is that it takes human language to tell the computer to do something for them. So, but human language is naturally ambiguous, and which means that the output of the computer will be probabilistic, which means that every time you tell it the same natural human language, different result might come true. So these are the two differences of the von Neumann computing era and the large language computing era. The first one is that the programming was using programming language and not natural intent-based natural language. The interface are mostly mouse and keyboard, whereas with the interface of large language model computing, it is going to be images, conversations, and whatever that human being generally are accustomed to. Most likely, it's going to use unstructured text, and it has wide range of dynamic reasoning capability. And once upon a time, all the software are based on whatever data and knowledge that you imbue into the software. But any large language model from now on will based software will have the internet scale knowledge to be imbued with them. We just need to take them out from it and make sure that the user will be able to use it properly. So what are the large language model computing paradigm get to use is that you get to, especially in a bank such as the Right Bank, just so you know, Right Bank is a bank that I'm working for. It's a new digital bank in YTL. So what we did is that human will be able to talk or type to the large language model interface, or we can use artifacts generated for human consumptions, and the input will go to different computing agents, AI agents, to process them and do tasks for the specific users. And these are the specific example of it, with text, with voice, and with images going into our Right Bank app, and it is able to do payment agents, deposit agent, and onboarding agents. So these are the example of AI agents that I was talking about. So what's a new thing that you can do, right? Like once upon a time, so these are the kind of interface that you can say, like, pay Shafiq 26 ringgit for lunch. You can even like combine two actions together, like send 214 ringgit to these two numbers that you know for ang paos, or you can combine two different actions as well, as you can see. So this is designed for all sort of users, especially someone like my mom, who spend 8 hours in Facebook every day, but cannot do CIMB transfer. So this is an example of video of how this kind of interface work. This is live, by the way, so you can actually download it from the App Store, open a bank account, and try this out. So as you can see, you can do math on the fly as well. It's very natural languages. So you confirm, and the agent will take your instruction and be able to do everything for you here. So, and in the bank, at the back end too, for risk management, what we can do is to consume a whole bunch of artifacts that were created by for human, such as news articles. So we take news articles from a myriad of sources, such as Bloomberg, Wall Street Journal, and Financial Times, and be able to use it to generate risk ratings and signal. And this is only possible in the large language model computing, because the computer actually understands the natural language that is written in the news article. And in turn, how an AI agent can be manifested in user interface can be seen with this example. So this is literally my bill, not very halal. So it is able to understand a handwritten and be able to, so it is like having a teller to read your invoice and be able to do transfer for you. So what does it mean? Like, it used to be that like the user interface will talk to the user. Used to be that the users are the probabilistic party, which is us. And then the user interface will translate the probabilistic to deterministic in the API. But in this day and age, there will be, the UX have to take two things into consideration, two probabilistic channel into consideration, the users and the large language model, and in turn will turn everything into deterministic to the API. So, so in the future, I think as we can see from the banking app, a lot of our transaction is going to be conversational, and it is going to be towards like having dialogue with AI rather than having dialogue with other people. So these are some of the examples as well. So this is the example of how, so this is why like someone like my mom is so comfortable in using this, because it will try to coach you as well not just with the rigid user interface that we have in Maybank or CIMB, but this is literally going to be coaching you as to every single step based on what you just typed in. So this is an example of how it is doing something that natural language is quite easy to do, which is show all my transaction with Mike, and it is something that actually most banking interface cannot do right now. Because if you want to show all the, to know all of your transactions with Mike in CIMB right now, you have to scroll all of them. And you can see how this is already achieving something that is out of ordinary. So we are moving from our menu-based type of UX to search-based UX that if you have Mac OS or PC, you are quite familiar with. And then now we have context-based UX, right? Like the UX that understand what you are trying to do rather than you are searching. So, and I think in the future, what we're going to have is that we have just-in-time UX as well, where the user interface is generated specifically for your specific need within that time frame. So, so that was with the banking agents. So now we are going to talk a little bit about another type of agents that we use in the bank and in AI labs on a daily basis, which are the coding agents, right? So, and generally, the type of agents that we use fall into three types: the prototyping agents, coding co-pilot, and code-based system to team, right? So I'll explain what is that. For the prototyping, these are the two tools that we use a lot of times. It's called Replit and Vercel. And so both of the tools will be able, you can input natural language, and it will be able to create prototype from end to end, from the user interface to media tier to database layer, just on the fly. So what it does is that you have like predominantly non-coders, such as PMs, will be able to prompt the LLMs. The LLM will be able to write code, and immediately it will generate the whole working program like this. And then the second one will be the tools that are going to be used by programmers, software developers. This is what the type of tool that I call co-pilot, which is like your assistant to the programmers. And these are generally these are the two tools that are being used: Cursor and Lovables. And Cursor, I think, is one of the fastest growing company ever in human history. This is how useful it is from a revenue standpoint. So what it does is that a software developer will be able to prompt LLM, and LLM will be able to display some code. It will be able to examine it and modify it so that it works for their situation. And then the human computer, the human programmer will then upload it into and deploy it as a system. So the third type of system is called System 2 systems for software development, so, System 2 agents. And what it does is that it input like millions of lines of codes, and then it examine all of it. It will take a long time for it to examine everything. And then after that, it will be able to start doing some of the tasks that you want it to do. So it will import your entire code base, so which means that all of your enterprise intelligence will be imported into these agents. And these agents are usually not one agent, are usually comprised of maybe hundreds of agents itself, right? So, and it has a most infinite code context. Most time than not, it has thousands of agents. One of the main things that we use it very often is auto documentation. And we can also do mass code generation, like saying, like, can you upgrade from Java 2 to Java 3? entirely, and then it will run for the weekend. You come back and you might have to fix some of the code, but most of the stuff will be done for you. So it can generate like, it's one of the few times any of the programmers out there, you don't usually have 100% code test coverage. This is one of the few times that you can just walk away during the weekend and you have like 100% test coverage all done by yourself. So this is the thing that gives birth to this kind of tools where you can see AI autonomy, which means that how long an AI agent get to think before it comes back to you, and the longer that it thinks, the more stuff that it can do for you, right? So you can see it used the attention time, what they call the AI attention time, used to double every 212 days, but it has been accelerating quite significantly lately. It has been doubling for the last like 118 days, and as you can see right now, it can go into doing its own stuff for 30 minutes, and it will be able to come back to you with reasonably good results, right? So what does that mean, right? In the next like maybe 2 years, it will be able to arrive at 2 hours, which means that it is at the cusp of human attention anyway, because most of us can only pay attention for about 2 hours. So what's the system? So there's a difference between system 1 and system 2. Much of our AI agents now are falling into system 1, where you ask them something, it will immediately tell you the result, right? Whereas the system 2 one will take like maybe 30 minutes to days before it tells you the results, and obviously it will do a lot more stuff. And this is based on Kahneman's way of thinking, think fast and think slow, and we are familiar with it. So this is the difference between like AI coding companions such as Copilot, which I think a lot of us are using today, versus something that is System 2, which some of us are using today. And with the usage of this kind of System 2 AI agents, it means a lot, even to the workforce that we have right now. So what does it mean, right? From Monday to Friday, you have the programmers that use System 1 AI agents and be able to generate code. But on Friday, what they will do is that they will prompt the System 2 tools to be able to generate programming over the weekend, so that they can come back and check on Monday. So you can see AI contribute about 30 to 40% over the weekdays when your programmer is at work, and when the programmers are not at work during the weekend, AI will contribute about 100% of the productivity. So which means that your programming productivity will never stop. So what does that mean, right? So if you think about in a programming environment, you have the product managers and you have the coders, right? And for the product managers, you have 80% of the time you think about what to build, and then 20% of the time you think about how to build, right? And coder is the other way around. 80% of the time you think about how to build, and 20% of the time you think about what to build. But with these kind of System 1 and System 2, and also prototyping agents, product manager will start building a lot of systems, because they can easily code systems without having very in-depth technical knowledge. So which means that it thinks a lot more about how to build, because it is actually building a significant system, and potentially less about what to build. And the coder having to build or potentially write less code have to start thinking about what to build. So they are more akin to product managers going forward. So which means that the unicorn that we have in the intersection, like people who can be product managers and coders, will be the unicorn of the future. So what does that mean, right? So in a digital product organization where we used to have 80% coders and 20% product managers, suddenly you have 10% product managers, 15% pure coders, and 75% product-minded coders. So, and finally, I'm going to talk a little about some of the intelligence layer that we built in AI Labs that power all of the AI agents that we had. It's called Ilmu. It's the Malaysia's first multi-model AI model. So what it does is that it takes in text, voice, and vision. And by the way, the bank, right bank, is actually being built by about 20-25 engineers to version 1, and it's all Malaysians, and it is the first bank in Malaysia that is entirely built from ground up by Malaysians, including the traditional banks. Thank you. And this is also the same thing. We are partnering with University of Malaya, and it's 100% made in Malaysia by Malaysians as well for Malaysians. And what we want to do is that we don't want to build a large language model that is really just good in Malaysian stuff or Bahasa Malaysia stuff, but we want to make sure that it's also good in other things as well, such as science, such as math, right? So what we did is that the first thing that we measure, obviously, is how good it is in Malay, using this benchmark that came up with. It's called Malay MMLU. MMLU is a popular benchmark that is developed by UC Berkeley. Malay MMLU is developed by UC of Malaya, and it measures how good we are, how good the large language model is with Malay and Malaysian knowledge, right? So obviously, Ilmu is ranked top of the world, and these are all the Southeast Asian large language model, and these are their scores. And not just that, we beat Llama as well, and DeepSeek, obviously, and the smartest, and definitely the smartest of all large language model. And interestingly, this was launched the weekend after GPT-5 was launched. So we were scared, like, what if GPT-5 will actually beat this? Then our launch will not have the sound that it has, right? But good thing is that GPT-5 is actually scoring less than GPT-4 and definitely less than Ilmu itself. And why is that, right? One of the first motivation to create Ilmu is that we realize if you go to ChatGPT to write an essay, it will write a good Malay essay for you, but it will sound Indonesian. It's very simple. It's simply because we have a lot more Indonesian artifacts, right? And part of the miracle of neural network, which is all this technology are built upon, is that it has the ability to abstract, which means that it has the ability to, understand similar stuff, right? Like you can show it the images of a cup, and from various angles, and then you show it a cup that it has never seen before, it will recognize that it's a cup. So which means that within the neural network, it understands the quality of cupness. So when we have more Indonesian artifacts versus Malay artifacts, it is very natural for it to veer towards Indonesian artifacts. And our prediction is that it's going to get worse because Indonesia are going to create more artifacts than us in Malaysia creating. And this is being reflected why GPT-5 is actually scoring less than GPT-4 in Malay language MMLU. So as I said, we don't want to build a large language model that is only good in Malay. Obviously, we want it to be good in other stuff as well. For example, Arena Hard Auto, which is one of the benchmarks that international large language model often base itself with, is higher than Llama 3.1. And this is IFEval, which is another benchmark that is a very popular benchmark around the world. It's called instruction following benchmark, a whole bunch of hard instruction for large language to follow. And we are neck to neck with GPT-4. So what does Ilmu stand for? It's Internet Luhur If you're not familiar with the word LOHO, it stands for integrity. I just learned that not too long ago as well. Malaysia, Unsukmu. And part of the intellect, and it shows that how ilmu can speak proper Malay. In this case, you can say Siapakah Hang Tuah, and this is a predominant large language model, and it will be able to answer quite accurately. However, you can see legendaries and sastra are not exactly Malay word per se, it is quite Indonesian. And whereas you can see ilmu will be able to answer in a much more Malay manner. Beyond that, because we ingest a whole bunch of forum data, so it is able to speak a lot of how Malaysian is speaking. In this particular sense, it is essentially combining 2 or 3 languages within a single sentence and including some abbreviation as well. Just because it is over-indexing on a lot of forum and chat data, it will be able to reply based on certain level of colloquialism as well. And of course, when we go to the palace, we speak differently. What they call the Bahasa Istana. And with this, it is able to say, to teach you how to speak in front of the royalty. And it's not just intelligence, it's Malaysian intelligence. So, and also it is based on like our integrity as well. Because, you know, most of the large language model are based on the integrity of either the Western integrity or the Chinese integrity, which is quite different from the Malaysian integrity, and we'll show you how it is. Like for example, if you're talking about marijuana, it might be reasonably permissible in certain culture, but in our case, we want to advise that it is highly not permissible, and these are the problems if you are caught with it. So, and beyond that, in speeches like this, usually if you ask ChatGPT to write you a speech, it will be able to write you a good speech, but it will be lack of certain things that we do all of the time, like for example, greeting Yang Berhormat Prime Minister, Yang Bahagia Tan Sri points and all those stuff. So it doesn't just understand, it's not just smart intelligence and understanding the law of it. It is able to understand the custom as well, simply because we ingest a lot of information about the custom. And for example, you know, wedding is important, and it is, I think for most of us, it doesn't happen in many times in your life, so you actually have to consult someone. And you can see how it will tell you exactly who to consult and where to consult. And it will also tell you exactly what is expected out of you, not by law, but by culture as well. So, and hopefully with that, it will lead to a happier mother-in-law. So one of the main things is that if you realize how the world is moving, we are more and more dependent on computing system and digital system, and we are going to get more and more dependent on them as well. So if we fail to own and control the system that we rely on, so we are at the risk of being led by this system that are not, that we didn't design in the first place. So if we use OpenAI or DeepSeek in our government, we will be predominantly being led by these two cultures rather than our own. So what we want to do is to demonstrate our capability, not a competition, because there are a lot of times you want to use other large language model because they are really good at certain things, right? We want to translate French, you probably want to use like something like Mistral, right? But we are just providing a capability that is not available anywhere else. And being sovereign doesn't mean isolation, it just means resilience, right? It just means that if somehow one day certain president of a superpower decide to withdraw all of open AI services, we still have certain level of intelligence within our government or GLCs. And we are not just do not want to rely on other. What we want is to complement with the global model, with the context, culture, and purpose. Malaysian context, culture, and purpose. So we don't want to be the users of AI. What we want to be is to be builders of AI as well. And case in point being, how we build the AI agents in the bank and everyone else. So, what we want to do is to guide the AI to preserve our national identities. And much more importantly, the word artificial intelligence is innately human. So it reflects our culture. It reflects our sensibility. So, and it's not just that what we have built thus far is that we built a full stack AI, not just that the large language model itself, but we have a data center as well, supported by AI Cloud, by NVIDIA, and this is our 500 megawatt data center in Kulai, Johor, that we built. And it holds one of the fastest NVIDIA supercomputer in the world. So we are builder of infrastructure, including LLM. What we think is that the LLM is infrastructure itself, and we are working with a whole bunch of people, including Kasem, Ecotech, which is the tech providers for Proton, and obviously Right Bank, Stripeys, Astro, and different type of companies that are building on top of us. Right now, there are more than 50 companies that are building on top of us, and any of you are welcome to apply to be able to build on top of Ilmu as well. And thank you very much.
All right, thank you. Again, to everybody who's currently right here with us, for those who have questions for our speakers, you may scan the QR code that is being displayed on screen to send them in. Selected questions will be shared with our speakers during this discussion segment. All right, here we go with the first question. All right, we have the first one right here. Beyond raw performance of Ilmu, Mr. Foong, what's your strategy for aligning the model's capabilities with real-world business or government use cases in Malaysia?
That's a very good question. So very soon we realized that after working with a few partners, we realized that we cannot possibly solve all the problems in Malaysia. So what we did is that we have the first program where we work with about 20 companies, where we empower the companies to solve their own problem using Ilmu. So, we deliberately choose a diverse set of companies from food safety to agriculture to healthcare to financial services to government services in such a way they use Ilmu to solve other people's, to solve their specific problems.
Thank you, Mr. Foong. We still have one more question. All right, let's take this one. The current AI innovation is in relation to the existing algorithm. So what happens when the algorithm is changed 5 years later? Will AI be impacted?
That's a very good question as well. That is the reason YTL AI Lab, this is, when you are the builder of this kind of AI, you realize that you build to 1.0, you immediately know what to do to build to 2.0. So what are the lacking things, right? Including from algorithmic standpoint and from the data standpoint. For example, Ilmu right now can speak Kedahan Malay, Terengganu Malay, Kelantanese Malay, but it is lack of the data of the East Malaysia. So essentially that's the next frontier that we want to go to. So right now, from an algorithmic standpoint, it is a transformer-based, what we call the dense model. what we want to do in the near future is also to potentially move to, as you can see from around the world, agent-based MOE models. So those are the kind of stuff that we need. We want to run this kind of innovation program for 10 years, 20 years, 30 years, and not stop at where it is right now.
All right, thank you, Mr. Foong, for that insightful presentation. And again, just a reminder to everyone that AI tech is more than just uploading cat memes on the internet. Before we proceed to the next session, we'd like to invite Mr. Foong for a very quick photo session on stage. Can we invite our photographers? Thank you so much. Okay, Mr. Foong, you can stand at the center of the stage. Thank you.